The number of elements in a set is called the cardinality of the set. And two sets A and B have the same cardinality if there exists a bijection phi which goes from the set A to the set B. And we have a little bit of notation here for this. If the sets A and B have the same cardinality, we can say that A equals B with little absolute value bars. That just denotes the cardinality. And this is best seen through an example here. So let's look at something pretty basic to start with. Show that the sets A and B have the same cardinality, where the set A is the set of numbers 1, 2, and 3, and the set B is the set of the numbers 4, 5, and 6. Well, in this case, it's pretty easy to see that they do have the same cardinality. There's 3 elements in the set A, so I can say that the cardinality of A is just 3. And there's 3 elements in the set B, so I can say that the cardinality of B also equals 3. But let's actually do this by finding a bijection. So in this case, we have the set A, which has the numbers 1, 2, and 3, and we have the set B, which has the numbers 4, 5, and 6. And I can define a map phi, which maps 1 to 4, 2 to 5, and 3 to 6. This is injective because nothing in the set B has more than one thing mapped to it, and it's surjective because there's something mapped to every element in the set B. And since phi is both injective and surjective, it's bijective. And this shows that A and B have the same cardinality. Okay, let's look at a more interesting example. Show that the set of integers has the same cardinality as the set of 3 times integers. So this 3z here that we've seen before, this 3z is the set that looks like, I guess I'll just write out some of the elements here so you can see. It looks something like -6, -9, -3, 0, 3, 6, 9, and so on. Okay, so that's what this set looks like. I put this in set notation here. Okay, so we need to find a bijection from the set of integers to the set of 3 times the set of integers. Well, if I want to bring each integer to some multiple of 3, it would make sense to maybe do something like phi of n goes to 3n. That way 1 will go to 3, 2 will go to 6, 3 will go to 9, -1 will go to -3. Okay, so this seems to work. So for the solution here, let phi be the function that goes from z to 3z given by phi of n equals 3n. And I need to show that this is a bijection in order to show that these two sets have the same cardinality. So first, let's show that it's injective. To show that it's injective, we can start by letting A and B be 2 elements of the set of integers such that phi of A equals phi of B. And the goal is to show that A equals B. Well, if phi of A equals phi of B, then 3A equals 3B, and that implies that A equals B, so phi is injective. To show that phi is surjective, I'm going to let y be some element of 3z, and I need to find an element x that gets mapped to y. Okay, well, if x is in the set of integers such that x equals y over 3, then I think that works, because then phi of x equals phi of y over 3, which equals 3 times y over 3, which equals y. So phi is surjective. And since phi is both injective and surjective, phi must be bijective, and this shows that the two sets have the same cardinality. Let's look at one more example. Show that the closed intervals 0, 1 and 0, 6 have the same cardinality. Okay, so first we need to find a bijection from 0, 1 to 0, 6. And this is usually the hardest part of the problem, is just finding the bijection in the first place. So in this case, since I have these 2 closed intervals, it would be nice to have something that maybe will map the 0 to the 0 and the 1 to the 6. In other words, kind of match up the endpoints here, 0 to 0 and 1 to 6. And I think if we just kind of scale the interval 0, 1 to 0, 6, maybe with a linear function, that should work. So how about something like phi of x goes to 6x? So 0 will get mapped to 0, 1 will get mapped to 6, and everything between 0 and 1 will be mapped to something between 0 and 6. I think this works. Now we have to show that it's a bijection. So let phi be the map from the closed interval 0, 1 to the closed interval 0, 6, given by phi of x equals 6x. So first, let's show that it's injective. To show that it's injective, I start by letting a and b be two elements of the closed interval 0, 1 such that phi of a equals phi of b. Well, that means that 6a equals 6b, and that implies that a equals b, so phi is injective. To show that phi is surjective, I start by letting y be some element of the closed interval 0, 6, and I have to find some element x that gets mapped to that y. Well, how about if we let x be y over 6? Then phi of x will equal phi of y over 6, which will equal 6 times y over 6, and that's y. So I found an x that got mapped to that y. So phi is surjective. And we know that if phi is both injective and surjective, then phi is bijective. And this means that the closed interval 0, 1 and the closed interval 0, 6 have the same cardinality.